Hey everyone, it's Mr. Rosenberg again. For this video, we're going to be going over Chapter 6, Section 2, Multiplying and Dividing Radical Expressions. And the objective of this section is, of course, to multiply and divide radical expressions. So let's get into it. So first, we're going to talk about the product and quotient properties of radicals. So if we take a look at this first picture right here, we have two numbers being multiplied together that have the same exponent, right? And we have 2 squared times 3 squared. Well, whenever we have something like that, if both of our terms have the same exponent, we can put both of those bases into a set of parentheses and have those numbers be multiplied together, and then raise that to the second power, right? It's the same thing they did with 4 cubed times 5 cubed. That's equal to 4 times 5 cubed. We can do the same thing with radicals, right? So if we remember the index from before, that's just that little number that we put inside, or not inside, but on the outside of our radical sign. So if you have two radicals that have the same index, we can multiply those together, right? So here, the square root of 2 times the square root of 3, well, that's the same thing as the square root of 2 times 3. And if you did that out, that would just give you the square root of 6. You can do the same thing for the cube root. We have the cube root of 4 times the cube root of 5. That's equal to the cube root of 4 times 5, which is equal to the cube root of 20. So that's multiplication. Now we can do the same thing with division, right? So with dividing, just like multiplication, if we have two radicals with the same index that are being divided to each other, we can basically just put that one radical over the entire fraction, right? So the square root of 2 over the square root of 3, that's just equal the square root of 2/3. Same here with the cube roots. The cube root of 4 over the cube root of 5, that's equal to the cube root of 4 over 5. And then just down here in this picture, we have a little more generalized statement that says if n root a and n root b are real numbers, then n root a times b equals n root a times n root b. And it's the same thing for fractions. The n root of a over b equals the n root of a over the n root of b. So let's take a look at an example. So if we have the square root of 8 times the square root of 5, well, we can use that product property to simplify. So if we go ahead, this is equal to the square root of 8 times 5, which is equal to the square root of 40. Now we can see 40 isn't a perfect square. So if we're met with something like this, there's a list of steps we can take to be able to simplify this further. So we did the first step, we multiplied using the product of radical properties. Now we want to find the largest perfect square factor of the radicand. Remember, the radicand is this number that's under our radical, right? So we have the square root of 40, and we want to find the largest perfect square factor of 40. So if we go through our factors of 40, we would see that the largest perfect square factor is 4, right? So we can rewrite the square root of 40 as the square root of 4 times the square root of 10, right? These two are equivalent to each other. So once we did that, we did this step, rewrite the square root of 40 as a product of its two factors. That's what we did right here. Now we can simplify each of those square roots, right? So we go one by one. The square root of 4, well, that's equal to 2. And then the square root of 10, that's also not a perfect square. So if we went to see if there were any perfect square factors, there isn't. So there's nothing we can do with that square root of 10. So we would just leave that in the square root of 10. So we would simplify this to 2 root 10. And that would be our simplified version of the square root of 40.